Welcome all to my channel. Today we are going to look at the difference between class boundary, class limits and class interval using a statistical data. So consider the data below. So we have the two data. We have data A, as you can see, and we have data B, as you can see. So we have two of them. So beginning with the first data. So the data is running through from, so I'm going to start by giving the difference between the first data and the second data here. So if you look at the first data is an inclusive data. So it is an inclusive. So as you can see, so if you look at the lower boundary here, it is 9.5, upper boundary is 14.5 as you go up to the last one. So here we have the upper boundary is 24.5, meaning it is inclusive. Here we have 29.5 inclusive, 34.5 inclusive. So the data is running from 10 to 14. Then in the next box we have 15. So from 14 we have 15. But if you look at the second data, from 10 to 15, then in the next box we have 15. So 15, 15. As you move, 25, 25, 30, 30. So as you can see. So if you end with the 25 here, the next table we are beginning with 25. If you end with 15, the next table you are beginning with 15. So this data here is called exclusive form of data, while this one is inclusive form of data. I hope you can see the difference between the two. So very quickly to the first data. So you can be told to state the upper boundary and the lower boundary of the model class. So the model class is the class with the highest frequency. So model class is 10 to 14. So the upper class boundary of this class here, 10 to 14. So if you look at this number, this is the upper number. So getting the upper class boundary, we are going to add 0.5 to this 14. So that's giving us 14.5. Well, if you want to get the lower boundary of this class, 10, we are going to take 10 minus 0.5 to get 9.5. So boundaries are given by adding or subtracting 0.5. But limits, we don't add anything or we don't subtract anything. You give the value the way it is. So like here, upper limit of the model class. So the model class is 10 to 14. So the upper limit will be 14, the lower limit will be 10. So you don't add or subtract, you just give the way it is. So you don't say the opposite. Some of you normally says that if you want to get the upper class limit, you add 0.5. If you want to get the lower class limit, you subtract 0.5. That's a very big wrong. You should not say that for the boundaries. Then the class interval. So the class interval here is given by the upper boundary minus lower boundary. So the class interval for the model class. So upper boundary is 14.5, lower boundary is 9.5. The difference is giving you 5. So that is what we have here. So class interval here is 5. Class interval here is the upper boundary, which is 24.5 minus 14.5. The lower boundary giving you 10. Here 29.5 minus 24.5 giving you 5. Here we have 34.5 minus 29.5 giving you 5. So class interval is also the same as the class size. So to the next table here, as you have seen the difference between the two. So here, this is exclusive data, so we don't add or subtract 0.5 when finding the upper boundary and the lower boundary respectively. So we don't add or subtract. So for example, if you want to get the upper boundary and the lower boundary of the model class. So the model class is here, 25 to 30. That's what we have. So the upper boundary of the model class will be 30. So you just pick it the way it is, because these are exclusive data. So the data is already in its upper class boundaries. So we don't add or subtract 0.5 because the data is already in its upper class boundaries. Then the lower boundary is 25. Then in this data here, this is where the upper the limits are the same as the boundaries. As you can see, the upper limit is also 30. The lower limit is also 25. Then the class size, it is upper boundary minus lower boundary, so 30 minus 25, 5. So here class interval 15 minus 10, 5, 25 minus 15, 10, 30 minus 25, 5, 35 minus 30, 15. So if you look at this data here, this is not a uniform data. So the uniform data, why it is not uniform? Because the class intervals are not the same, so the data is not uniform. So that tells you that when drawing a histogram for a data whose class interval is not uniform, you need to find frequency density. So in my next video, I'm going to show you how to draw a histogram for a data whose class interval is not uniform, and for a data whose class interval is uniform. Thank you. Hope all of you have understood. Please subscribe to my channel.